we're going to start factoring polynomials, our main objective for this video is to learn how to factor by grouping. So we're going to start with a polynomial. You know that a polynomial is a good candidate to factor by grouping if it has 4 terms. So I have 1, 2, 3, 4. So this would be a good one to potentially factor by grouping. Not all polynomials with 4 terms are going to factor by grouping, but this one is a good candidate. So to factor by grouping, I am going to group together my first 2 terms. So when I say group together, I'm just going to put them in parentheses. Then I'm going to group together my last 2 terms. My first step is to figure out what the GCF is in this first term. Remember, GCF is greatest common factor. I'm looking for the largest number, letter, or combination of the 2 that goes into each of these terms evenly. I'm not looking for something that goes into all 4, just something that goes into my first group. So when I look at these 2, x squared goes into each of them evenly. So I'm going to factor out an x squared. When I do that, what I'm left with is x minus 2. Then I'm going to go to my second set and find the GCF. Anytime this first term in the second set is a negative, you need to make sure that what you're factoring out, your GCF, is a negative. So I'm not just going to factor out a 9 here, I'm going to factor out a negative 9. So factoring out a negative 9, when I do that, I am left with x, and then positive 18 divided by negative 9 would be a negative 2. Now I have 2 sets. Again, I have x squared times x minus 2 and negative 9 times x minus 2. Each of these has an x minus 2 in parentheses. So now I'm going to factor out the x minus 2. So here's my x minus 2. Then I'm going to write what I have left. I have x squared minus 9. Once you get to this step, you need to look at your quadratic and see if it continues to factor. In this example, x squared minus 9, this is a difference of squared. X squared is a perfect square, 9 is a perfect square, so this one continues to factor further. So my final answer here is going to be x minus 2, and then when I factor this guy, it factors into x plus 3 times x minus 3. If I were to expand this out, multiply these 3 binomials together, what I would end up with is the polynomial that I started with. So these are my factors for this polynomial. So we're going to go through and try another one. The first thing you should always do, especially if your numbers are really large, is to look for a GCF. Look for a number that goes into all 4 of them and see if you can make your numbers a little smaller, more manageable. In this example, all 4 of these numbers are divisible by 3. So I'm going to first start by factoring out a 3. When I do that, I'm left with 2x to the third plus 14x squared plus x plus 7. Now I'm ready to take this polynomial with 4 terms and factor it by grouping. So I'm going to group the first 2 terms together and then the last 2 terms together. So I've got my 3. I'm going to look at my first 2 terms and figure out what my GCF is. What's the largest thing that goes into each of these? So 2 goes into both 2 and 14, and x squared goes into both x to the third and x squared. So I'm going to factor out a 2x squared. When I do that, what I'm going to be left with is x plus 7. Then I'm going to go to my second set, and I'm going to see what I can factor out. Here it doesn't really look like I can factor out anything. It doesn't look like anything goes into both of these. But remember that 1 will always go into everything. So I'm going to factor out a positive 1. Make sure that you write that down. You always have to put something here. Even if it doesn't look like anything factors out, you have to write something here. So when I factor out a 1, nothing changes. I'm still left with x plus 7. So now I've got my 3 that I originally started with. That was the first thing I factored out at the beginning of the problem. That doesn't just go away. Each of these has an x plus 7, so that's one of my factors, x plus 7. And now I'm going to look at what I was left with, 2x squared plus 1. That's why you have to write the plus 1. You can't just say that 2x squared is a factor, because it's not. The factor is 2x squared plus 1. Our last step is to look and see if our quadratic can factor further. The only time it's going to factor further is if it's a difference of perfect squares. So this is not a difference of perfect squares. So this is my final answer. These are my factors. For this next example, I would like for you to pause the video and work through this one on your own and see if you can figure it out correctly. And then once you hit play, I will go ahead and work through all of it still so that you can see what you did wrong if you didn't get it correct. So go ahead and pause it now and then hit play when you have an answer. Alright, so I'm going to group the first two and the last two together. I'm going to see what goes into both of these. That's an x squared. And what I'm left with is x plus 5. Then I'm going to look and see what goes into each of these. Remember, since this is negative, I need to make sure I'm factoring out something negative. So I'm going to factor out a negative 4. What I'm left with is x plus 5. Remember, we want what's in parentheses to end up being the same. So I'm going to start with what went into both of them. They each have an x plus 5. What I was left with was x squared minus 4. Then I look and see if I can factor this further. This is a perfect square and a perfect square, so I have a difference of perfect squares, so it can be factored further. So I have x plus 5. And then when I factor this, it factors into x plus 2 and x minus 2. So those are my factors. If you got the correct answer, great, you're ready to move on. If not, hopefully as we walk through it, you were able to find where your answer was. And I'd like for you to do it again. So I want you to pause the video, work through this problem, and then hit play as soon as you're done. Alright, so I'm going to group the first two terms together. First I'm going to look and see if anything goes into all of them, since my leading coefficient's not 1. Nothing goes into all of these evenly, so now I'm ready to group the first two terms together and the last two terms. I'm looking for a GCF. Here my GCF is x squared. When I factor out an x squared, I have a 3x plus 4. Over here, I'm going to factor out a positive 5, so I'm going to write plus 5. When I factor out a positive 5, I have 3x plus 4 left over. Then I'm going to write what they each have in common. They each have a 3x plus 4. Then I'm going to collect everything that was left over, so I had an x squared plus 5, so that's my next one. I'm going to look at my quadratic and see if it can factor further. X squared plus 5 is not a difference of perfect squares, so I'm going to leave it alone. This is my final answer. This is fully factored. 3x plus 4 times x plus 5. So now you're ready to go ahead and do the homework that is posted on the right.